Hi, this is I Teach You Again on YouTube and I'm Neon. If you are not yet subscribed our YouTube channel, it's your time to subscribe and don't forget to give us a like. This is the third session of our set of lessons and is about the fundamentals of electrical technology. Hence, in this tutorial, we will be covered the definition of electric current, theory of electricity and properties, SI units and RMS or root mean square value of AC signal from A to Z with the purpose of bringing our viewers a clear and thorough understanding. So let's start the session hereafter. What is electric current? The electric current is the rate of flow of electric charge through a conducting medium with respect to time. When there is a potential difference between 2 points in a conductive medium, electric charge starts flowing from the higher potential point to the lower potential point to balance the charge distribution between the points. The rate of flow of charge in respect of time is known as electric current. Current formula. If Q coulomb electric charge gets transferred between these 2 points in time t sec, then the current can be calculated as I equal Q divided by T. Similarly, in differential form, the current can be represented as I equal dQ over dt. Unit of current. As the current is the ratio of transferred charge to the time taken for this charge transferring, we can say 1 unit current is such a rate of charge transferring in which 1 coulomb charge is transferred from one point to another in 1 second. Hence, unit of current is coulomb per second and it is well known as ampere after the great physicist Andrew Marie Ampere. This is SI unit of electric current. Theory of electricity. Current in metallic conductor. The main cause of current through a metallic substance is the flow of electrons, that is, the directional drift of free electrons. In metal, even at room temperature, there are plenty of free electrons exist inside the metallic crystal structure. When electric potential between 2 points in the metal differs, the free electrons which were randomly moving at equilibrium potential condition and also the free electrons supplied by the source, if a source is connected between these 2 points, now get drifted towards higher potential point due to electrostatic attraction. As each of the electrons has a negative charge of 1.602 times 10 to the power of minus 19 coulomb, it can be said that the negative charge gets shifted towards higher potential point. The rate of flow of this negative charge in respect of time is the current in the metal. Conventional direction of current. Although the flow of electrons or negative charges from lower potential point to higher potential point, but the conventional direction of current is considered from higher potential to lower potential. Although current is mainly caused by the flow of electrons, that is, the flow of negative charge, but previously it was thought that the electrical current is due to the flow of positive change. But now it is proved that the current in a metallic conductor is due to flow of electrons or negative charge, but the direction of current is still considered as it was accepted previously, that is opposite of flow of electrons. The direction of the current which is considered from a higher potential point to a lower potential point is known as the conventional direction of current. Types of current. Type 1. Direct current DC. When current flows in one direction, either in constant or fluctuating manner, the current is called direct current. Type 2. Alternating current AC. When current flows in either direction alternatingly in a frequency is called alternating current. The average value of an alternating current is 0. The alternating current is measured in RMS value. One main parameter of alternating current is frequency. Magnetic effect of current. When current flows through a conductor, there will be a magnetic field surrounding the conductor. The direction of the lines of force of the magnetic field can be determined by right-hand grid rule. If we imagine that we have held the current-carrying conductor with our right hand with extended thumb along the direction of the current, then 4 fingers of our right hand indicate the direction of lines of force of the magnetic field. See the demonstration of right-hand rule. When we make a coil with a conductor and current flows through the coil, then due to magnetic effect of each conductor of the coil, there will be an overall magnetic field surrounding the coil. Here we can also determine the direction of the field by right-hand grid rule. If we hold the current-carrying coil with our 4 fingers along the direction of current in the turns of the coil, then the extended thumb indicates the direction of the magnetic field. Current in magnetic field. When we place a current-carrying conductor or a current-carrying coil in a magnetic field, a mechanical force acts on the current-carrying conductor or coil. This mechanical force depends on the current through the conductor or coil. Measurement of current. Depending on the principle of interaction between current and magnetic field, one can measure the current. One of the basic instruments to measure the current is PMMC instrument or permanent magnet moving coil instrument. The PMMC instrument is only able to measure direct current. The alternating current can be measured by moving iron instrument, where magnetic field created by current through the instrument coil causes movement of a soft iron piece either by attraction or repulsion force. This instrument can also measure direct current. Rectifier-type instruments are also used to measure alternating current. Here bridge rectifier is used to rectify alternating current, then it is measured with PMMC instrument. Wherever may be the types of current measuring instrument, in one word, all current measuring instruments are called ammeter. An ammeter is always connected in series with the path of which the current to be measured. When very high current is to be measured, we use current transformers to step down current for measuring purpose. When very high current is to be measured, we use current transformers to step down current for measuring purpose. Heating effect of current. Give your attention to the representation given here. When current flows through a conductor, there is a heating effect in the conductor. The loss of power in the conductor is I squared XR watts. The loss of energy is I squared XR xt joules. This loss of energy is converted to heat. Hence this is known as Joule's law of heating. SI units. Units are defined as those tools using which we can measure any physical quantities effectively. For example, if we want to measure length, then that can be measured in meters, centimeters, feet, etc. Again, if we have to measure mass, then that can be measured in kilograms, grams, etc. So from the above example, we can say that there are many units which can be used to measure a particular quantity. Now if we take the other physical quantities also, then there are many units available for a particular quantity. Now, this leads to the confusion in ourselves. One may ask that which one should we choose and which one we should not choose for measurement. If many units available, then there may be some conversion factor to convert it into the other unit, but that is very clumsy, and also there is a high chance of error in doing that, and if we require to measure that particular unit in the third unit that is available for the quantity, we may end up getting the erroneous result. So there is an absolute necessity for choosing standard quantities in measurement. In this case, what we do is we choose a single unit for a particular quantity. That unit is known as standard unit. Most of the measurements are done in that unit. So the measurement becomes simple, but also it gives importance in a single unit for a particular quantity. Most of us know what SI units, but we do not know what SI means. It simply means international systems of units. The units which are taken in measuring physical quantities are collectively called as SI units. It is developed and recommended by General Conference on Weights and Measures in 1971 for international usage in scientific, technical, industrial and commercial work. Now the problem arises is, what units should we choose? The units chosen must have the following qualities. It must have a suitable size. It should be accurately defined. It must have an easy access. It must be time independent. It should not change with a change in physical quantities. The SI units which are represented without the help of other quantities that are known as fundamental quantities such as length, temperature, etc. The units which can be represented by the help of the fundamental units are called derived units. The fundamental quantities and the standard units, SI, are given below in a table. Advantages of SI system of units. It is a coherent system of units. It is a rational system of units. SI is a metric system. Though it has great advantages, and now we use SI units for most of the measurements, but it is not free from disadvantages too. It has disadvantages such as it mainly focuses on only one unit, so the importance of other units is diluted. Also, the SI unit cannot always accurately define a quantity. For example, in case of a measurement of the area covered by a house, we use square feet as the unit of area in most of the cases, so in those situations we may have to convert to the SI units, which is not desirable. Such a case may arise in the other situations also, but the advantages of SI systems are more dominant, so it is so popular and we use it quite often. RMS, or root mean square value of AC signal. Before understanding RMS, it's better to list up the questions frequently asking by most of the people. Why RMS values are used in AC system? What does an average and RMS value mean? Why all the ratings of AC systems are in RMS, not in average value? What is the difference between RMS and average value? These are the questions that come in our minds every time when we're dealing with AC circuits. Suppose we have a simple DC circuit, figure 1, and we want to replicate it in an AC circuit. We got everything same except supply voltage, which is now to be an AC supply voltage. Now, the question is, what should be the value of AC supply voltage so that our circuit works exactly same as that of DC? DC circuit. Let us put the same value of AC supply voltage, AC V peak equals 10 volt, which is in our DC circuit. By doing that, we can see, figure 3, for a half cycle, how the AC voltage signal is not covering up the whole area, blue area, of constant DC voltage, which means our AC signal cannot supply the same amount of power as our DC supply. Which means we must increase the AC voltage to cover the same area and see if it is supplying the same amount of power or not. AC signal. We found that figure 4, by increasing the peak voltage V peak up to pi 2 times of DC supply voltage, we can actually cover the whole area of DC in AC. When the AC voltage signal completely represents the DC voltage signal, then that value of DC signal is called the average value of AC signal. Now our AC voltage should supply the same amount of power. But when we switched on the supply, surprisingly, we found that AC voltage is supplying more power than the DC. Because an average value of AC supplies same amount of charges but not the same amount of power. So, to get same amount of power from our AC supply, we must decrease our AC supply voltage. We found that by decreasing the peak voltage V peak up to square root 2 times DC voltage, we get same amount of power flowing in both the circuits. When the AC voltage signal supply same amount of power as in DC, then that value of DC voltage is called root mean square or RMS value of AC. We are always concerned about how much power is flowing through our circuits irrespective of how much electrons are needed to supply that power, and that is the reason why we always use the RMS value of AC supply instead of average value everywhere in AC system. Average value of an AC current represents the equal amount of charges in DC current. RMS value of an AC current represents the equal amount of power in DC current. AC current takes less amount of charges to supply the same amount of DC power. So this is the end of lesson number 3, and we'll see you back on our lesson number 4. Make sure you do not forget to subscribe us and give a like. See you there and have a nice day. Thank you.